In progress.
Hello and welcome to my professional development workshop. My name is George Allen. So today the plan is to develop staff skills in improving data literacy throughout iSTEM learning, building modelling practices and examining socio-scientific issues. This is to be implemented at a Year 7-8 level, and this workshop is designed to support staff members who may have none or very limited exposure to modelling in the past, particularly using Google Sheets or other spreadsheet-based software. So the aim is to provide examples of hands-on modelling activities that can be applied to a Year 7 or 8 STEM classroom to staff who may have not had prior experience in this area, as I said before. And you can see the Australian curriculum links, which have all been taken from the Year 8 curriculum across the F to 10 version 9 Australian curriculum, um, taken from maths, taken from science, taken from digital literacy, and taken from numeracy. So you can see the applications of mathematical modelling are really broad and can span a significant number of content areas. So a bit of a plan of attack for today, for the workshop sequence and for what is going to be happening is we'll start with a bit of an introduction. You've already had a little bit of that, but I'd also like to talk about the use and relevance of models that we as teachers can apply when looking at student data and creating projections for the way that students may perform. I think it's a bit of fun. It's something that I enjoy doing. This first activity then will be constructing a classroom model. Very simple, very practical, very applied. Any teacher with very few resources should be able to generate this data. And it's a nice introduction activity for our students as well to familiarize ourselves with the software. Activity two is then constructing a socio-scientific model using Google Sheets. And for that, we're going to focus on the not insignificant world issue of climate change and carbon dioxide emissions. Once we've done that, then we're going to have a bit of a conclusion with self-reflection and some feedback there as well. All right, so just to start us off with, when I can get my screen to then work so I can see everything that I want. Oh, it's down here actually. This is a bit of modeling that I do in my own time. So sometimes for a bit of fun, I enjoy doing some mathematical modeling, particularly as I'm in Victoria, relating students' NAPLAN performances and comparing them to project them to be, the scale's going a bit funny on some of these, projecting them to indicate the study scores or the BCE performance of some of these students, so what we can expect. And so what I've done is, as the study score is a percentile-based metric, I've taken the NAPLAN reading and the NAPLAN numeracy scores for different percentiles, and I've plotted them against what the equivalent VCE study score that would be. So you can see the study score along the y-axis, and you can see the NAPLAN reading score here along the x-axis. And so you can see if you were in the 25th percentile, that would, a 25 study score, that would equate to score the equivalent percentile of about 523, probably there. And so what I can do from that model is I'm able to then use some of this formula, some of these formulae to pull out the mathematical relationship that we see here. Um, the function of this line, I can then plug in a whole class worth of data for NAPLAN numeracy or NAPLAN reading, which then, by using that formula, it then spits out what is effectively an anticipated study score for these students. And I don't know how this would work in a non-Victorian context. However, I can only presume that other states may have similar systems and you can use similar sorts of models in your own way of working. Okay. So, our first activity, we're going to be looking at modeling bivariate data. So modeling class height. This is a really easy and fun activity that I think most students are going to be able to engage with. And we'll get into the what, and then we'll talk about the why. All right, so if I come back to my handy Google Sheets that I've got open, and you see I've got all the links available here in the PowerPoint as well, and so you'll have access to those links if and as you need them. PowerPoint will be available after. So here's an example of a data set that I have collected with my class just a couple of days ago. This was a Year 9 maths class, and we were familiarizing ourselves with these concepts. And what I did, I got the students to jump onto just this very easy to find time and date website, and I asked them to type in their birthday. I'm not going to type in my own birthday, but I will type in a date. 05, let's say I was born on the 5th of February in the year 2000. I wish I was that young. And we'll go today, and then we'll calculate duration. And that's going to tell me how many days ago that was. And so I've asked each student to essentially tell me how many days old they are. Something that's really interesting and personal and relevant to them. I've also asked them to calculate their, or measure their height. And so this is encouraging a bit of group work here as well. So we've been able to plot that out. We've plotted out some class data here. Once we've done that, we're going to highlight all of those cells. We're going to insert a chart, and that is going to produce a chart that looks something like this. And now you may be able to see, this is a Year 9 class, you may be able to see an obvious outlier. And this is a great thing in these early discussions. We can start introducing students to the concept of cleaning up data, looking and discussing some of those meaningful points of data that are anomalous or maybe wrong. And sometimes when we're modeling, those anomalies are the story. And sometimes those anomalies confuse the story. And so you want to look into why those anomalies occur. So I'm looking at this data and I'm thinking, wow, there is an obvious outlier here. Someone is significantly older than everyone else. And that is this figure right here. And so you might ask your students to have a conversation about why that's the case. Is that person representative of the class? Or is there an anomaly there? And you'd be hoping that students would be able to pick out that that is you as the teacher there. And also maybe hoping that students don't go and then use that to calculate your own age. And you may want to fudge that by a few days or a few hundred days, depending upon how you feel. And so how we're going to treat this data, I think it's not that relevant. And we can then just talk about removing that data by highlighting it and pressing delete. And all of a sudden, this looks a lot better. So what we're going to do now, we're going to double click on the spreadsheet. We are on the graph. We're going to go to series. We are going to go to trend line. We're going to go to label, and we're going to use equation. We're also going to show R squared. So we can talk about the R squared value here being a measure of how well the line fits our data. And so an R squared value of close to 1 means that it's fitting our data really well. An R squared value of closer to 0 means it's not fitting our data that well. Maybe our data is more spread, maybe it's not so linear. But again, there is a really meaningful opportunity for discussion there, and everyone's classes are going to be different. My imagination, with no actual understanding, is that's more likely to be more linear with your younger students, and then as students have variously stopped growing or not, it will change. And so it's a great opportunity to start those discussions. So I'm just going to come back here. Why don't we do that? You can see all that on the board, but it lets our students get familiar with everything in a meaningful, hands-on way, working as groups, discussing things that are important to them. I've met a lot of teenagers, and things that are important to them are often them. And so they love getting that understanding and building that connection between how the mathematical model works and who they are. Okay. We're running a little bit lower on time, but the second activity is another modeling activity based upon that. So what I've done is I've gone and I've collected some CO2 data, which is available on NOAA's website, and some land temperature available, which is also available at the National Centres for Environmental Information. I've got those links there, and you can see those links if I just wait for my Zoom to move out the way. You can see those links are available. So no, I'm going to choose to use CO2. You may choose to use CH4, N2O, SF6 as and give your students opportunity to make their own choices and do their own extension if they want. And so we're going to go through and basically conduct exactly the same process. And you're going to produce a line that looks like this. So it might require a little bit of cleaning up um, in terms of relabeling things, but you'll produce your average monthly CO2 and your temperature anomaly, which is also measured monthly. And you can see since 1958, since March 1958, that data is up current till 2025, and you can see that trend there. What we want to do with this data, though, is we can build upon this and turn it into a proper model. So we're going to insert that trend line again. And we'll use this equation here. But what we can also do is we can use this formula here. So it's line est, and basically that produces the actual values so that you can use them and do mathematical operations with them to create a mathematical model. So I'm going to use my temperature anomaly as my y data, as you can see there, and I find that easy to work out if I've got the graphical representation, and I'm sure your students will as well. My X data, that's going to be my average monthly CO2. I'm going to press true there and then false for the second one. And what that does is it produces my line in a formula that looks like this. If I didn't do that, it wouldn't produce the plus C or plus B value that you might know it as. So this is my M value, my gradient, and then this is produced as my C value. And again, you may choose to set students up for this, but what I've done is I've created a model that students can use. So I've asked them, in here we've got some inputs. So I've got input of what year I want them to look at. I've got the input for what is that yearly increase in CO2 that I want them to look at. And you can see from Australian government policy, students can look at, they're aiming for net zero, but students could choose to have a look at what that looks like if we hit net zero from 2025 levels. They could look at, you can change this model and have a look at net zero from, say, 2020 levels. But for now, we're going to keep it at the 2025 levels. A yearly increase in CO2 of zero is going to keep the CO2 levels at about 428 ppm. And I've got some formulae in here, and I'm not sure that I'll have time to go into it, but I've taken the average value, the average CO2 levels for the year, and then I've multiplied that by the increase in years times by the increase in CO2 that I've been predicting, put into the model here. And then from there, I've put in my formula, my CO2 levels multiplied by my gradient, plus my y-intercept, and that will produce a temperature anomaly. And you can see that if I have a 1 ppm per annum increase in CO2, and I can put that in 2.2, all the way, if I have a 10 ppm per annum increase in CO2, you can see the temperature anomaly, the increase in above the median temperature will be 6 degrees. And so students can do their own investigations with that, which gives them a real power and opportunity. So this allows students to develop modeling capabilities using real world data. This data is data that is produced by scientists. It is the current contemporary data. It is accurate, and it allows them to discuss real world socio-scientific issues. And it allows students to build into complex concepts. What does net zero mean in terms of a temperature increase? And what does not doing that mean in terms of a temperature increase? So there's a lot of opportunity for differentiation in here. Students can do more or less of the work. Students can then, having had a look at this, create their own models using different gases and see what the effects there look like. Um, all students could evaluate different things. Instead of temperature anomaly, the data sets available have sea level data and have all sorts of other data like ice coverage and things like that. Where are we? Here we go. All right. So, in terms of the team actions, teams should meet to plan and practice build familiarity and fluency with the modeling software. So that's what I want my team to do. And identify suitable data sets that you could conduct similar tasks with. Obviously, you'd want to then meet to discuss opportunities for growth and extension and supporting students with additional needs. And we really want to allow staff to build that culture to support each other and to be able to help each other become experts using this sort of modeling. So, in order to do that, we'd use a peer-based observation model, which pairs an experienced peer with a non-experienced peer and looking at fortnightly observations with the idea that we would conduct a gallery walk of student modeling tasks at the end of the term. So as a part of that, we're using the explicit instructional strategies. So this is about me giving these staff, giving everyone who needs the skills. And it's about respecting staff time and agency. It's about also providing skills to people who may not have the skills in the most efficient way. So, in terms of my ability to evaluate, I want to get some immediate feedback in the form of a survey. So, the survey looks like this, and that link is accessible through the PowerPoint. On top of that, I also want to be looking at these peer observations and reflections, and that's going to help us hopefully build some relational trust, allowing these professional conversations to take place and professional support to take place. And then we'll have a bit of a celebration with a gallery walk at the end. There's my reference slide, and thank you very much for listening to my presentation. I'm very grateful. Thank you.